Hey, what's up guys? This is Aaron from Clever Programmer again. And today I just want to talk about something really cool in Python called indexing, slicing, and striding in arrays and strings. So let's get started. Alright, first you're gonna want to go to REPL.it as usual. So once you're here, click on new REPL and follow along please. Why is Python not popping up at the top? That is just perverse. Anyways, so let's just name this, what did I say? Indexing, slicing, and striding. So that might not make any sense to you right now, but I'm about to explain. So this is a really cool thing that you can do in Python to play around with strings and arrays. Strings are basically just arrays, but yeah, you're able to do a lot of cool things with it. So I'll just jump right in. First, let's start with a list. So I'm just gonna call this list digits, and then I'm just gonna put the digits from 1 to 9 here, or 0 to 9. So there's 10 digits in here, right? And these are actually the same as the indexes of every digit. That might make it a little bit easier for you guys to understand. So once we have that there, you guys should be familiar with simple indexing. If you're not, please look it up real quick and come back. But if you do, then you should know that if I go like this, digits at 0, then this is just going to print out the first element of this array. So it's just going to print out 0. Let's see if it does, and that's exactly what happens. Same deal, if I put in 1 or 2 or 3 or 4, then I'm just going to get that same index back. All right, one thing you might not have known about Python, I'm not sure of any other languages you can do this in. I'm sure there are, but I don't think you can in Java or C++ or other languages like that. But you can actually use negative indexing. So let's, what would that even mean? Like, think about it for a second. If you had a negative index in an array, what could that possibly mean? Maybe you could be like indexing through it, and then maybe like you start, you loop around to the beginning again. Like once you loop too much, like almost like a modulus. But actually, what Python decided to do, which I think is pretty intelligent, is actually make it so that you count from the back of the list. So if we're indexing with positive numbers, this will be 0, this will be 1, this will be 2, 3, so on and so forth. Oops. But if you use a negative index, let's just say -1, you would actually be accessing this last one. So let's try print this out. And as you can see, the very last element is printed out. If I put -2, again, the second to last element is printed out, 8. So actually, if I wanted to get the very first element using a negative index, then you could actually just put -10 because there's 10 elements in this array. Or even better, just put negative, just use the length function. You guys know the length function. If you don't, then it just gives you the length of any list or string, I believe. I'm not sure if it works on strings, but I think it does. So yeah, see if we do that, then this automatically becomes 10, this makes it negative, and then we can get the first element that way. So you can actually call every element by 2 different names in Python. That's really cool. It's very handy if you just want to get the last element, just boom, just like slap in -1 and you're done. It's very nice and easy and clean. Another cool thing we can do is there's actually going to be a lot of cool action happening between these two brackets. You can do a lot of stuff between these two, with like multiple colon signs and weird little codes. But it's very, very powerful for doing different kind of reading from arrays and strings. So what else you can do is let's stick a colon in here. So what the heck does that mean? All right, so all this means is you can actually put a range of an array in here. So that means instead of just putting in like a single element, you can actually put a range of elements. So let's say if I wanted to just get the first 2 elements, or the first 3, so 0, 1, 2, I would leave nothing in the beginning, and then let's say we would end at element 3. So it'll go up to 3 but not include it. So it'll actually give us this entire thing back instead of just one element. So you can actually reference parts of the array in chunks, and you can specify exactly the chunks you want. So let's try to run this and see what happens. Exactly what I thought would happen. 0, 1, 2, because this will start from the very beginning because we didn't specify anything here. I think if you put 0, the same thing would actually work. Yeah, because it starts from here, includes this, so this number is inclusive and this number is exclusive. So this will print out everything from 0, 1, and 2. Likewise, if I put it all the way up to 9, this will go from 0 all the way up to 8. So I would actually get from 0 to 8 here when I run it. And yep, that's exactly what happens. So that's basically what slicing is in Python. Very useful if you just want to get like a chunk of it. Let's say you had like a name in a string. Like maybe let's just pop this in here real quick. name equals first last. Just like that. Go like this, and let's say I just want to pick out the first name. You can actually find the correct index, so 0, 1, 2, 3, 4, 5. And if I put 0 to 5, and you can actually just get rid of the 0 because it's the same thing as nothing, and I run it, first prints out. So see how you can get a different substring from that string? Very cool in Python. I'll just get rid of this because I guess we don't need it. Let's go back to this example. So also you can also slice into arrays using negative elements. So you can actually put in like a -1 like this. And this should be from the very first element to the very last element. Remember, this is exclusive, so it's not going to include the 9. Let's try that. And again, the same thing pops out. Also, I believe you can, yeah, this is one thing I almost forgot to do. You can put a number at the beginning and leave the last part empty, so that this will go from element 5 inclusive all the way to the end. Note though, if you put 10 here, 10, index 10 here, you're actually going to exclude it. But if you just don't put anything at all, you'll actually include the last digit. So that's something to keep in mind there. What else can we do? So I think that's about it when it comes to slicing. Also, another thing you can do is called striding. So slicing is very simple. You just put you have a chunk. You can just get any range in the array you want, 1, 0, up to all of it. But you can also do stride. So that's actually going to incorporate 2 colons. All right. So what this means is you can actually have a slice here. So let's say from 0 to 10, right? Or let's say to 10. And then what the stride is how big the jumps you want to be. So if the stride was 1, we're just going to hop 1 time every time. So it's going to go from 0 to 1 to 2 to 3 to 4 to 5 to 6, etc. But if you put 2, you can actually skip. So it'll actually jump and skip from 0 to 2 to 4 to 6. So we can actually pick out all the even numbers this way. Let's try this. I'll run this, and as you can see, we get 0, 2, 4, 6, 8. If we put in 3, then you'll actually jump in strides of 3. So you get 0, 3, 6, 9. You might not get the 9 because this is 10. Let's see. It did pop up. So the 9 did pop up there. Those are basically what strides do. Again, you can use negative indexes here in any combination you want. You can omit things. So if you omit the first one, you're going to start from the very beginning, including this one. If you omit this one, you're going to do include all of them all the way up to the end. Also, you could do something like this. So this just includes everything. This is just everything. And a stride of 1 just includes everything. But let's say you put a stride of 2. Then you just get the even numbers. Or you could even actually use negative strides as well. I forgot for a second, but I believe if you put a negative stride, what would that mean? Remember the negative index, we actually, the negative index you would start from the end of the array, but what about a stride? A stride kind of tells you, okay, jump in a certain direction at a certain jump. So a stride of 2, you would jump in leaps of 2, in strides of 2, you would keep jumping over and over and over. Or strides of 3, you would jump over and over and over and over in strides of 3, leaps of 3. So a -1, what makes most sense, what the people who designed Python came up with, was if it's negative, go backwards. So actually putting a stride of -1, you'll start from the end of the list and you'll go backwards. So let's see how that works. Let's click run. And as you can see, the list gets spit out backwards. So this is actually a cool little thing that you can do in Python to reverse any array or string. Just stick a little -1 here. Also, if you put a -2 and you hit run, then the same thing happens. It starts from the end and goes to the beginning of the array, but it's going in strides of 2, hence the only odd numbers here. Very cool. One thing to note with negative strides is if you have negative strides and you also want to slice, you need to make sure that this index here is on the right side of this index here. So I can't put like index 0 here and index 5 here because that doesn't make any sense. How can I go from index 5 to index 0? Sorry, I have it backwards. This way. How can I go from index 0 to index 5 going in this direction to the left? It doesn't make any sense. So you need to make sure that the stride direction, if it's positive or negative, that the slicing indexes also make sense. They're in the right order. So you need to make sure that if it's negative, then the slicing is going to the left, and then if the stride is a positive number, then the slicing is going to the right. So this would not work. This would work, but if we have a -2, then we would need to actually change these to 5 and 0, so that we are going from 5 to 0 in strides of 2. So it would be 5, 3, 1. And that's exactly what happens. So that might have been a little bit confusing. They're very, very useful thing once you figure out how to use them. Just play around with it a little bit. I'm kind of rambling on a little bit here, but if you just like pop in some numbers with these 2 colons and really figure out like what happens and try to predict what's coming out the way I did, then it'll actually be a really good learning exercise for you. So why don't you go in there and do some cool stuff, like just play around, get some substrings, get some like subarrays, and reverse some things and go in the opposite direction and just have fun with it. All right, so that's pretty much it when it comes to indexing, slicing, and striding, including negative numbers. But now I actually want to do a little example where instead of just having numbers in these slices, you can actually use variables. So one little cool thing that I came up with was if we just have a for loop called for I in range, how many digits I have? 10? Yeah, but let's just put length. Use the length function because that's more robust. You're able to make the program smarter that way because it'll automatically adjust. So always use the length function instead of hard coding numbers. Try to never hard code numbers in your code. It's just not a good idea when you are trying to make big programs. So length of digits would end up being 10. So for range in 10, let's try to just print out digits from the beginning to I. This 0 is optional, but I'll just put it in there for clarity's sake. Let's run this, and before I do though, what do you think will print out? Think about it, and I'm gonna run it now and you'll see. So you can ignore this. This is from that first print statement, but this is exactly what prints out here. This weird cascading thing here. Now think about what's happening here. We have a loop with a variable I that goes through the digits here from 0 to 9, and then each time we go through this loop, we want to print from the beginning of the list up to that digit. So every time this loop goes, I is getting a little bit bigger, which means this is going from the beginning to somewhere, and then beginning to somewhere a little bit bigger, and the beginning to somewhere a little bit bigger, beginning to somewhere a little bit bigger, and so on and so forth. And that's why you get this. You start at the beginning, and then you go from the beginning to 1, and then beginning to 2, and so on and so forth, all the way until you get to the end at 8. So this is a little bit advanced, putting variables in slices, but you can actually do some really interesting things when you're doing like complicated algorithms and whatnot, putting variables in slices like this with strides. And you could even put like equations in these slices and whatnot, like modulus signs and weird function calls and stuff, and you can put a lot in there, and you can actually do some really interesting things when it comes to grouping together things. So let's say one actually kind of advanced example that I came up with, but I really want to show you guys. It's pretty cool. It's, let's say I have this list from 0 to 9 here. Now let's say I want to get every group of 3 possible in this list. So if I have this entire list, I want to get 0, 1, 2. I want to get 1, 2, 3. 1, 2, 3. I want to get 2, 3, 4. 3, 4, 5. So on and so forth, all the way up until 7, 8, 9. All right, but no further. I don't want 8. I don't want just 8, 9. I don't want just 9. I don't want just 0. Okay. So you can actually let's start by writing a for loop again. So for I in range, let's just go length of digits again. Let's just start there. That's always a good place to start. Sometimes you have to like subtract 1 or 2 to get rid of some weird offsets, but just start by using the length function always. And let's just try to print digits from I to I plus 3. So let's think about this before I run it, okay? For I in range, the length of digits, so this loop is going to run 10 times because this list is 10 elements long. Then every time this runs, we are going to go from the current index, so whatever iteration we're on, so 0, 1, 2, 3, or all the way up to 9, plus 3. So the current index plus 3. So what is this defining here? This is defining a slice in the array. Okay. A slice in the array of size 3, but it's constantly moving because this is I and I plus 3, then we know that it's going to be of length 3 wherever I is. So let's just try to run this and see what pops out. Let's comment this out so the output doesn't get confusing. Boom, boom, boom. Run. So as we can see, it almost has the correct functionality that we want. 0, 1, 2, 1, 2, 3, 2, 3, 4, 3, 4, 5, because you can see like the first elements of all this output, these are actually the iterations of the for loop. And then we just added 3 to the end of the slice. So that's where we get the second 2 following numbers after that. So that's how we do that. But what about this thing here? There's this 8, 9, and 9, but I want to get rid of that because those aren't groups of 3. So let's think about that. What could you do to get rid of those? Well, you could just subtract 2 iterations from the for loop, right? You could just chop it off just by putting a -2 in here, a little cheeky -2. Boom, and you just get rid of those 2 and just ignore them completely. But that's not the best idea. Usually you don't want negative, just the same way I didn't want to put 10 here. I used length of digits instead. You also don't want to do a -2 or a +3 here even. Just bear with me for a second. It might make a little more sense once you see it. So you don't want this -2 or +3, but then how do you get rid of that? Well, let's just say I said I wanted a window size, right? Window size of 3. So let's do that. Now let's get rid of this. So suddenly we can get rid of that 3. So this should run exactly the same as before. Boom, yes, it runs exactly and does what we want us to do. And we actually specified the window size here. So that's really cool, but we still have this -2 here. So what does that mean? How do we get rid of that? Well, let's think about what this 2 is really doing. This 2 is subtracting off 2 iterations of the loop because there is a trailing, some trailing things. Like once these iterations over here happen, there's not enough digits afterwards to get an entire group of 3. So what the key distinction I want to make here is that 2 is 1 digit less than 3. All right, because let's say I put actually, let's get rid of this and I'll just show you guys. If the window size was actually 5, so now I can change. See, this is actually another good reason why you want to have variables like this, because you can just change one variable. See, I changed this one variable to 5, and then now I can actually change the window size to 5. So I can get these 5, and then these 5, and then these 5, and so on and so forth in chunks. Or even I can just go the entire array. I can get all 10 elements at once. But let's just go with 5 and run this and see what happens. So you can see that it's running as expected. We're getting groups of 5 from 0 to 4, and then 1 to 5, and 2 to 6, and so on. But we have all this junk at the end again. But do you notice how we actually don't only have 2 iterations, there's actually 4 iterations. So remember, we had 3 iterations and we had to get rid of 2 iterations. And now there's 4 extra iterations. So 3 and 2, the difference is 1. And then now there's 4 iterations, or the window size was 5, and we had to get rid of 4 iterations. So you see how 5 and 4, their difference is 1 again. So we found the relationship between these two numbers. This number always needs to be 1 less than this number in order for this window size thing to work. Okay, does that make sense? If it doesn't, try to rewatch that whole little section again and think about the relationship between these two numbers. Why would this weird ramp thing here get longer as this number gets bigger? So if I put in a 6, this ramp got one longer. If I put in a 7, this ramp got even one longer. So we got to keep getting rid of one more iteration of the for loop at the end every single time. Once you understand that, then it's very simple, because all you need to do is we need to subtract 6 from here. If you need to subtract 6 from here, 6 is 1 less than 7. And what is 7? 7 is window size. So actually, let's just put instead of -6, let's go minus window size. But remember, it has to be 1 less than window size, so -1. There is one exception to the rule. Every now and then you will actually need to have a -1 or a +1 to get rid of like weird offsets and whatnot. So it's okay to have -1s or +1s in your code, but you never ever want like a negative like 427.76 or something like that, because then it's hard coded in the program, and that's not what you want in a robust, well-rounded program. So -1 is okay. But when we run this, let's click run and see what happens. As you can see, oh, what happened here? Oops. Yeah, as you can see, we get all the groups of 7. Actually, we don't. What is happening here? Did I make a mistake? Alright guys, thanks for standing by. I had to take a couple minutes to figure that out. This kind of stuff happens all the time, like even when you plan stuff out. So just be aware that even people who have been programming for like 7 years like me, they still screw up. It was actually a very simple bug here. What I realized was, yes, this number does need to be one more than this number, but earlier I did not have the parentheses here. So when I was doing this, it was actually subtracting I think it was subtracting the numbers incorrectly. But once I grouped it together here by putting these parentheses in, I feel like that shouldn't change anything, but for some reason that has fixed the issue. So if I wanted to get groups of windows of size 7 now, this will actually become 6 within this parentheses. So I can do this, and as you can see, now we get all 4 instead of what we had before. I believe this is what we had, and this was giving us errors. But yeah, I guess sometimes it's always safer to use parentheses, more parentheses than less parentheses, to be very, very clear about your order of operations, because that's a very easy mistake to make in math. And then those same easy mistakes translate over to programming very, very smoothly, which is actually kind of a negative thing, but also a positive thing if you know how to work out math problems. But just be aware of that. Any math that doesn't work in real life won't work on a computer. All right, that's just something to note. But yeah, that's the last kind of advanced example I wanted to give you guys with slicing. So here we're actually using a dynamic slicing scheme here to actually change the slice in a for loop over and over again. So we're actually playing around with some numbers, and then all we have to do is change one number up here, one little configuration thing, and we can actually get any size window we want. So this is every window of size 1, every window of size 2, like you guys get it, so on and so forth. So yeah guys, that is the end of this video. I might have drone on for a little bit. I'm trying to get better at that. I noticed I drag on a little bit, but I like to be more verbose than less verbose, because I think it's better to be clear and then to just watch the video on like 2x speed, because that's kind of what I learned in my my own personal schooling. I'm currently in graduate school. But yeah, stay tuned. Thanks for watching guys, and I'll see you next time. I'm going to be releasing a bunch of new YouTube videos in these next few weeks. Leading up to this, a lot of cool content for you guys, but actually all this stuff is actually a lead up to this new product we're going to be launching called How to Automate Stuff with Python. Yes, how to automate stuff with Python. It is exactly what it sounds like pretty much. You're going to be automating a lot of stuff on your computer with Python. It's actually pretty cool. But yeah, I just want to mention that in there. Stay tuned to hear more about it. I'll be talking about it more in the future, but definitely a very, very cool course. We're gonna be going over a lot of stuff like automation, cool little like automating mouse clicks and keyboard presses on your computer while you're not even there, stuff like that, like really, really cool stuff. But definitely stay tuned, and that is all for this video guys. Thank you for watching, and I will see you next time. Goodbye.